Hello again, 8th graders. This is Chapter 4, 8a on square roots. And first of all, I want you to take a good look at your calculators, because there's a difference in how you do square roots if you have a 30xa or if you have a 30x to Roman numeral 2s. On the 30xa, you have a key, it's 2 keys above the 9. If you want to do the square root of 144, for example, you'll have to put in 144 first, then you'll have to hit the square root of x key, and then press equals. Now, if you have a x to s, you are going to have to look at your x squared key. If you look on the left side, you go from on, the way end left column, you move all the way up and you'll see an x squared key. And then above the x squared key, on the base of on the frame of your calculator, you will see a square root key. That means you have to hit second function. Now yours is a little different. You're going to hit second function key, then the square root key, it's actually the x squared key, then you would type in 144, and press equals, and it'll come out as 12. So I would suggest you practice that before we begin the lesson. Although many of the numbers that we're going to be using are actually numbers that you will not need to use a calculator for. First of all, you have to understand the definition for square root. A square root is a number that when multiplied by itself is equal to the given number. So let's look at example A. The square root is the number multiplied by itself that will give me 16. Now if I think of all the factors of 16, 1 and 16, 2 and 8, 4 times 4. 4 times 4 is the square root. Now the truth is, the square root is both 4 and negative 4. 4 times 4 is 16, and negative 4 times negative 4 is also 16. So we have both a positive square root and a negative square root. If we look at example B, you should be able to tell me that the square root of 25 is 5 and negative 5. You try C. Yes, it's 6 and negative 6. So what do we do with D? When we have a fraction like this, it really means we're going to take the square root of 9 over the square root of 16. Now the square root of 9 is 3, the square root of 16 is 4, or it's going to be negative 3/4. Now you've got to be careful not to put the negative on both the 3 and the 4. It's only on the one of them, and we usually just take it up to put it up by the numerator. So now you try E. Yes, we are going to get 12 over 13 and negative 12/13. Sometimes though, oh, I forgot to go over this. Boom, back here we go. Okay, all the numbers that we've used here, the 36, the 25, the 9, the 144, the 169, etc., are what we call perfect squares. So some numbers are perfect squares because their square roots are integers. So 0 is a perfect square, 1's a perfect square, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. And 14 times 14 is 196. 15 squared is going to be 225. 16 squared would give us 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And of course 20 squared is going to be 400. Those are probably the most common perfect squares you're going to be facing. Most of the time they will not go past probably the 256, although they will give you numbers like 400, 900, 1600, etc. And those are like 20, 30 squared, 40 squared, etc. Okay? Now, what about numbers that are not perfect squares? The best we can do here, right now anyway, is estimate those square roots. So we look at the square root of 28 and we think to ourselves, all right, 28 is between perfect squares of 35 and 36. This is why having a perfect square list is kind of nice. 28 is going to be between, it's going to be somewhere up here, okay? So we look at it and say, all right, 28, however, is closest to 25. It's far closer to 25 than it is to 36. So a reasonable estimate is going to be 5. So we look at 38. Okay, if we go back to our perfect square list, 38 is going to be between 36 and 49. So we're between 36 and 49. Now 38 is going to be closer to 36. So 38 is between 36 and 49. 38 is closer to 36. So a good estimate for the square root of 38 is going to be 6. So you try 105. Okay, 105 is between 100 and 121. 105 is closer to 100. So the square root of 105 is going to be approximately 10. Now, the negative sign is always put in last. The truth is, you cannot take the square root of a negative number. However, you'll notice that this negative sign is outside of it. What this really says is we are going to take the opposite of the square root of 105. One of the places to use this is in a formula for the speed of sound in meters per second for a given air temperature T. In science class we did talk about this, or we will, depending upon if you've had physical science yet or not. Sound is actually varies according to the air temperature, because temperature can actually allow the molecules of air to speed up or to slow down. Now, again, we're working with a formula, so just like the other day, the first thing you're going to do is write down your formula. 20 times the square root of 273 plus T, where T stands for temperature. So the speed of sound is going to be 20 times 273 plus 10 in this particular case. That means your speed of sound is going to be 20 times the square root of 283. The best way of doing this is to actually take your square root of 283 first, and then multiply by 20. There is a difference in how the two types of calculators handle it, but really you can use your commutative property, so just take your square root of 283 first, and then times 20. You'll notice that your decimal doesn't really terminate and it doesn't really repeat. So we are going to take the approximate. Generally speaking, you are going to round off to the nearest whole number, and then you're going to need your label of meters per second. At this point, hit pause and you try B. Again, we're going to write down the formula, then we substitute. So our speed is going to be 20 times the square root of 253. And that is going to be approximately 318 meters per second. That concludes lesson 4.8a on square roots. Scout out.